Today we'll learn how to use the three famous formulae that you found last time. We'll learn how to solve problems. Stay tuned. So great, you're back, amigos. Today we meet to learn how to solve trigonometry problems using the SOH CAH and TOA formulae. I bet you need a small review on equations first, because trigonometry is turning triangles into equations. By the way, what's an equation? Nobody? I do it myself. An equation is an equality in which there is an unknown, and you need to find out how much is the unknown. A solution to an equation is any number that makes the equality true. These are equations. This is also an equation because there are two unknowns. You can't find the solution for sure. There are many couples of solutions. For example, this one or that one. Solving an equation means doing some tricks to isolate the unknown on one side while all known things get gathered on the other side where they can be calculated. First of all, let's make it clear. 5a means 5 times a, just like 5 elephants means 5 times 1 elephant. But of course, ab means a times b. Here we'll use two main tools to solve equations. The first one is cross multiplication. We've seen that a few times recently. Cross multiplication is used when you have a fraction equal to another fraction. The unknown may be any of the four numbers, but cross multiplication is only useful if the unknown is at the bottom. The cross multiplication is a transformation from an unpleasant fractional form into something flat. So you have a over b equals c over d. This equality is totally equivalent to a times d equals b times c. So if your unknown was one of the denominators, for example b, now it's back at the ground level and it feels better. The second tool, I call it the antibody. You know, your unknown is never alone. It's polluted by other numbers around and you want to make them go away. For each pollution, there is an antibody. Here is how it works. Plus 4 is neutralized by minus 4, and minus 4 by plus 4. Times 4 is neutralized by divided by 4, and divided by 4 by times 4. But there's one important rule. If you apply the antibody, you have to do it on both sides of the equation. Let's take an example. 5x plus 3 equals 38. We get rid of the plus 3 with its antibody minus 3, so 5x equals 35. And we get rid of the 5 times with its antibody divided by 5, so x equals 35 divided by 5, which is 7. And before we get back to trigonometry, my advice, seriously, you won't go anywhere if you don't know your times tables. Nobody can do it for you. Learn them by heart. Take a few days. You will use them your whole life. Times tables are just essential. Learning them is the best investment you can make in your life. I mean, besides buying bitcoins 10 years ago. Wonderful. Now we're ready for trigonometry. First of all, we have three formulae. Each formula involves an angle and two sides. How do we choose which formula we're going to use? Basically, you need to state first the information you have. Every formula can become an equation, and you can solve it only if there's one and only one unknown in it, which means that in the formula you choose, you need to have two informations out of three. Let's say that we know the adjacent and the opposite. Let's put in red what we know. As you can see, the TOA formula is the only one with 2 out of 3 informations, so it will be our choice. Even if the angle is not the information you're looking for, because knowing the angle will allow you looking for more information. Let's say that now we know the angle and the hypotenuse. Knowing the angle means that you know the sine, the cosine, and the tangent. You just need a calculator for that. Let's put that in red. Here, two formulae have 2 informations, so we'll choose the one that answers the question you're asked. Are you looking for the opposite or for the adjacent? Now, if you know the opposite and the angle, what will you do? Knowing the angle means knowing the sine, the cosine, and the tangent. Let's put that in red, as well as the opposite. Here, obviously, we have 2 choices, so you will choose the formula that gives you what you want, whether it is the hypotenuse or the adjacent. So, how to take on a trigonometry problem? First, find the right angle triangle. Teachers can be mean. I know it because I'm a teacher myself and I can be amazingly mean. We sometimes try to hide the right angle triangle. So your first job is to defeat us and find it. Example, look at this and read the first question and determine where is the right angle triangle that we will study. Once you've found your right angle triangle, state clearly what you know and what you're looking for. We know the hypotenuse and the adjacent, and we're looking for the angle. Let's give a name to this angle. I always choose theta because it's the easiest one to draw. Among the three formulae, which one can be used? Let's put in red what we know. Obviously, it's the CAH formula. We can write it, replace adjacent and hypotenuse by their values, and that's all. We use the reverse function on our calculator and find an angle of 31 degrees. So, remember, 1. Find the right angle triangle. 2. State what you know. 3. State what you're looking for. 4. Choose the right formula. 5. Solve the equation. And 6. If you're looking for the angle, use the reverse function on your calculator. So now we can go to the second question. It's a bit more tricky because it's not a one-step thing. We need to find the area. And this area is made of several areas, so we need to identify them first. Then we'll keep that aside and go back to them at the end. Obviously, the area of the wall can be made of one rectangle and two congruent triangles, the same triangle that we've worked on at the beginning. So we need to calculate the area of this triangle. Do we have all the information for that? What is the formula of the area of a triangle? Base times height divided by 2, because basically it's half of a rectangle. So let's state what we know. The hypotenuse, the adjacent, which is the base, the angle. We don't have the opposite, which is the height. We need to find the opposite first. This is where trigonometry is going to help. Let's put in red what we know. Knowing the angle means knowing the sine, the cosine, and the tangent, all in red. We put the adjacent and the hypotenuse in red too. SOH and TOA can both be used. I'm going to use SOH because why not? Both formulae will give us the same result anyway. Sine 31 equals opposite divided by hypotenuse. I want opposite alone, so I need to neutralize divided by hypotenuse with a proper antibody, which is multiplied by the hypotenuse. So I get opposite equals hypotenuse times sine 31. Hypotenuse is 7. 7 times sine 31 equals 3.6. Now we have all the information we need to calculate the area of the triangle. Base times height divided by 2 is 6 times 3.6 divided by 2. But we're not looking for the area of one triangle, but two triangles. So we multiply all this by 2, and this neutralizes the divided by 2, which is a good thing because it saves us a calculation. That makes 21.6 square meters. Now we just have to add the rectangle, so 9 times 12 equals 108. We add the rectangle area to the triangle's area, and that makes 129.6 square meters. We're done. So remember that we had to proceed at different levels. So when you're facing a trigonometry problem, or a problem in which you believe that trigonometry may help you, identify first the right angle triangle, state what you know, and see if there's a formula that can give you the info you're looking for. If not, maybe you'll have to work in 2 or even 3 steps. One more thing, an important one that I didn't respect here. You shouldn't calculate intermediary results unless there are numbers with a finite amount of decimals. Otherwise, you calculate only at the end to get more accurate results. So what did I do wrong? In the second question, I considered that the angle was 31 degrees, but it was an approximation, and I used that approximation to calculate something else. That's really bad. I should have kept as a value of the angle the inverse cosine of 6/7, and this is what I should have used in my calculation of the area of the triangle. But often you'll be asked to calculate intermediary results, and they will tell you how many decimals you should round the result to. Take it as a permission to use your approximate results for the next calculation. Basically, it's because they are not interested in precise results, but in your ability to solve the problem. But in real life and concrete problems, we calculate only at the very end for a better accuracy. Great! If you can, have your parents tip me for my work on Patreon. If you're a teacher using my videos in a school, get them support me. The link is below. If you can't, no problem. You can still help me with a like, a comment, or by sharing, which also helps a friend. Thanks for watching and have a very great day.